Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hi guys, welcome to a brand new episode of the Clear to Send podcast. Today we're gonna talk about 5G, and I'm here today with Roel. Hey Roel, how are you?
Hello, good afternoon.
Good afternoon, and we have Andrew Von Nagy with us today. Hey Andrew, how are you?
Hey Francois, hey Roel, how are you guys?
Doing great. It's great to have you on the show because we haven't had you here before.
Yeah, thanks for having me.
Remember we had him for the FedEx episode.
Oh yeah, that's right. Yeah, we talked. You didn't talk too much, Andrew. It was more like Ubiquity trying to talk about their FedEx installation, how they incorporated your capacity planner, which I still use, by the way.
Thank you. Yeah, it was a good project to be involved with.
Yeah, so it is good to have you back on the show, but this time more focused on what you're doing and the technologies you're working on. So you're actually going to help me and Francois out in learning more about 5G.
Yeah, looking forward to it, to learning all about the Gs.
There's too many Gs. So Andrew, why don't we start by just you introducing yourself? Just tell us who you are, what you do, who you work for, and maybe you can tell us how you got started in Wi-Fi or wireless in general.
Yeah, absolutely. So Andrew Von Nagy, I am the Director of Solutions Engineering for Celona. Celona is a startup in the private cellular space for private 4G and 5G networks that are consumable and applicable to enterprise environments. So my background has been in enterprise networking for 20 plus years, mainly focused on route switch security and Wi-Fi in the enterprise space. So your traditional networking infrastructure within a corporation or an enterprise setting. How I got my start into Wi-Fi and wireless technologies is kind of by happenstance. I was studying my CCNA and CCSP and going down that track, and was really interested in not only routing, switching, WAN technologies, but I kind of fell into security as well. So I was doing a lot with open source IDS, IPS. I don't know if you guys remember Snort back before they got acquired a couple of times. Back when they were a truly open source project, I did a lot of that type of work. PIX firewalls back in the day, NetScreen firewalls, things of that nature. And back then, this was probably in the 2003, 2004 timeframe. Wireless was really becoming more widespread than it was at that point. So I was tasked with making wireless deployable across a school district, actually. And given the lots of talk and articles about the insecure nature of Wi-Fi and wireless, it fell to me kind of as the security guy to, hey, make Wi-Fi secure for our environments. So that's kind of how I fell into it. And from there, I actually, did a couple of projects in Wi-Fi for the school district, and, was intrigued by it, but not enough really to go down that path as a career. And then I got hired by Target Corporation, the large Fortune 50 retailer, and they actually interviewed me for 3 different positions at the same time. And they said, which one would be your preference? And my options were on the switching team, on the voice over IP team, or on the wireless team, meaning Wi-Fi. And I said, well, if I had to rank them, I was really interested in voice at that time. I'm like, I'd like to really do a lot of voice work. Switching's interesting. I know quite a bit about it. And then my third would be wireless. And wouldn't you know it, they had the biggest need in wireless. And they said, well, we're going to go ahead and put you on the wireless team. And I was kind of off to the races. And so I did wireless architecture for warehouses and stores and office spaces for Target for a number of years, and kind of along that path got my CWNE and my CCIE wireless with Cisco, and kind of was off to the races. And from there, I've worked at a few Wi-Fi manufacturers with Aerohive and Airtight, which is now Mojo, part of Arista, and also for managed service providers in the Minnesota Twin Cities area. So, and now I'm with Celona. I decided to, change it up and learn some new technology, as we all love to in the IT space. And I figured I've been keeping my eye on CBRS and the privatization, if you will, of cellular technologies, and thought it was a big opportunity. And so I jumped at the chance when a few industry peers of mine talked to me about Celona and said, "Hey, there's an opportunity here. It's really early on with this company, and it's really early on with this market. Would you like to help build it?" And I said, "Absolutely."
Awesome. That's a nice story. It's funny. I started on the security side as well, so I guess I can relate a little bit to your story. And then I got introduced to Wi-Fi, and that changed the game for me as well, I guess.
Yeah, there were just so many opportunities in wireless because it was so new back in the early 2000s that there's just a big void to fill with talent and just plenty of runway to grow in your career there.
Yeah, there's just a lot of unknowns in wireless, whereas you had a lot of people in the wired space and security space, but not enough people sharing their experiences on the wireless side.
Yeah, absolutely. And I think that's, I also was fortuitous enough to have my own personal blog at Revolution Wi-Fi for a number of years, kind of as that growth curve really hit. So a lot of people were out there looking for information, and so chalk up a lot of my success not only to dedication and learning and advancing my skills, but also to just luck and timing. I think quite a bit, and can't be overlooked. Timing is everything.
Yeah, and you also can't discount how much your consistency was with the site and the quality of the content. Like those two, like the content you provided, I think propelled my knowledge in Wi-Fi. It was you and Keith that really helped me understand Wi-Fi in the beginning when I knew I was doing it wrong, and you helped me and you enlightened me on, here's what I need to do or get started with. And I would watch your Arrowhive videos. I remember those.
Thank you. I appreciate that. I mean, I think we all, coming from the wireless or Wi-Fi space, can all point back to those initial projects when we were learning the technology. Yeah. And I look back at the ones I did and I'm like, oh man, like that's like APs in hallways and, mounted on walls, pointing the wrong direction. I'm like, what was I doing? But, I had these tools that were very nascent in the day, like the Cisco WCS. I'm like, oh, what if I drop an AP here and an AP here? Oh, look, I have the map good. Tells me it looks pretty.
Yeah, now it's a lot more in that.
Yeah, so I mean, I learned a lot by doing in those days because there wasn't a lot of material out there. Even for like when I got my CCIE wireless, there was just not much material, and it was all just, hey, lab everything up, do it, trial and error, make some mistakes, learn from it, and off you go.
Yeah, and so what made you make this transition from being only like an enterprise Wi-Fi guy to now doing cellular type of technologies, and especially 5G and private I can't even say the word, private cellular in the enterprise?
Yeah. I would say for me personally, I've always had a pretty big interest in emerging technologies, and not that cellular is an emerging technology. It's actually very mature, but it's an emerging market for the technology and new use cases for the technology. And that was really an exciting aspect for me. So just like I was interested, like I told you, in voice over IP back in the day when that was fairly nascent and people were trying to adopt it. It's the same thing here for private 4G and 5G in enterprises. It's one of those things where as a Wi-Fi professional, I always felt that I didn't know enough about cellular to really make a comparison. And then I'd always read those articles out on the web or by analysts and things that say, things of the nature like LTE and 4G are just way more efficient than Wi-Fi, and the carriers always like to, kind of tout the technology and thumb their nose down a little bit at Wi-Fi. And I really had just an interest of like, what's this all about? I really need to, buckle down and learn it so I can understand what those differences are. And with the CBRS spectrum opening up the opportunity to deploy your own cellular networks and not have it be operated and owned and managed by a large mobile network operator. I felt the timing was just right to learn the technology, to figure out how it's applicable to a private enterprise, how they can take advantage of it, and meet some business needs that they necessarily aren't solving today, or maybe new business opportunities that are opening up because of this technology and the adoption of it. So, I think that it's very rare that something that we call innovative is actually truly like a new technology or something brand new that's invented. I think a lot of it has to come down to new ways to use technology. So,
Right.
the new combinations of such that bring more value than was previously, brought to bear. So that was really the impetus for me is, hey, I'm a wireless professional. Wi-Fi is one technology, but I like to, have multiple options. And so it's like that with any technology. I think if you go back and look in my early career, I was big into WAN technologies, and so I do frame relay, and I'd look at T1s and DS3s and just multiple options to solve the same problem, and they all have their pros and cons, their advantages and disadvantages, and certain ones fit a situation better than others. And so I felt like in the enterprise space, we've had Wi-Fi, we've had iterations on Wi-Fi, but it still, has use cases that it's great for and use cases that it's okay with a lot of effort, and then use cases that frankly are very, very difficult, if not almost impossible to solve with it. So I thought, well, this is maybe another option to have that can solve some of those problems and be complementary to Wi-Fi and just be another tool in the tool bag for people to use. So I wanted to know more about it.
Yeah, it's and when you start looking into it, it's an interesting technology. I know back when I attended university, we had a course on cellular, and I was like, that was everyone's favorite course, and everyone wanted to work in the cellular industry. And I think one or two guys managed to do it, but they didn't have a lot of jobs in that space back in the days. They had more jobs in the working in the network team of a company. Right, but everyone was really into it, and at the time we're studying 3G, 2G. They didn't have 4G yet, or LTE. So but yeah, it's a very interesting technology as well, and it's a little bit different from Wi-Fi, from what we know in Wi-Fi, but some of the technology behind it is similar as well. So sometimes we can relate some of the things we do in Wi-Fi to the way cellular work, and then in other cases it's totally different. So talking about 5G in general, do you want to? How would you introduce? How would you present 5G to people who have never heard about it, or just heard the 5G term but never understand really what's behind it? How would you introduce 5G?
Yeah, well, I think, maybe I can take 20 seconds and just recap what the different, iterations of cellular technologies mean when we had, one in first gen, which was, analog voice, second gen or 2G, which was digital voice, but still kind of like circuit switched type of infrastructure. 3G brought in a combination of data into the mix, so it's not just voice, but still primarily circuit switch type of infrastructure, like with 3G with edge technologies and things like that. 4G was really your first all IP kind of cellular standard with LTE on the radio layer. And so then 5G is really just an evolution of 4G LTE. So it increases speed and reliability. It reduces latency across the network. It enables more advanced use cases, like when we get into talking about some massive IoT or massive machine type communications. And it also broadens the spectrum bands that cellular can operate in. So traditionally, cellular technologies have operated in a lot of low to mid-band spectrum. So low band being sub 600 megahertz and mid-band being 600 megahertz up to 6 gigahertz. Some very select bands in there that are a lot of times licensed or previously were exclusively licensed. Now we have, with 5G, some more mid-band options. So one of those is CBRS, which is the 3.55 to 3.7 gigahertz. which we're going to focus on for the private enterprise use cases. There's C-band, which is opening up, which is just above CBRS, which is 3.7 to 4.2 gigahertz opening up. There's 6 gigahertz options for unlicensed that 5G can operate in. So I know there was that whole, debate a few years ago, moving up to, present even about cellular operating in unlicensed and how those would coexist. I think they've settled on, some good coexistence mechanisms with license-assisted access and things like that. So 5G can operate in the 6 gigahertz unlicensed band. It's still kind of up in the air about how much that's going to be adopted, since the FCC has adopted, pretty favorable regulations for Wi-Fi and 6 gigahertz, but there still might be some 5G deployed in that band. And then one of the big things that you hear about with 5G is where you get some of the huge marketing terms as far as the speeds that are possible is really up in the millimeter wave, 60 gigahertz type of frequency ranges up there, where very, very short wavelengths, very short distances, like mainly in-room type of scenarios, but you can get very massive speed off of 5G. So those are really some of the highlights, is just, evolving LTE into higher speed, lower latency, and new spectrum bands.
So it's a combination of different technologies rolling up into 5G. So that's what 5G really is just the fifth generation, but encompassing like CBRS, C-band, potentially 6 gigahertz operation, and also the millimeter wave, which has been around for a long time as well.
Yeah, and then there's a lot of underlying physical and MAC layer radio changes as well. So it does require new hardware at the radio layer. So if you see the term 5G NR, it means 5G new radio. There's changes to the front end, RF front ends for how that operates. There's changes to the MAC and protocol layer, and some of those are very important, and we can dig into a few of those and why they're important. But yeah, so it's more than just spectrum bands. It's a lot of several critical changes to the protocol itself as well.
And how would a Wi-Fi professional approach this? Because they might be looking at it and maybe there's a use case that they could use it, but I guess some of my questions around it go, all right, when would you even consider 5G versus Wi-Fi? And then how would you even design for it? Or do you have to design for it like how we do it with Wi-Fi?
Yeah, so I think if you're a Wi-Fi engineer and you're looking at 5G or private cellular networks, the question is why would you be considering it, or why would you be interested in it? And I think the key things are that now it's more accessible than it has been in the past. I mean, cellular networks and 4G and 5G have always kind of been locked behind carrier doors, right? You can't access it, you can't deploy it yourself. The barrier to entry is fairly high, and that barrier is coming down. So now, if you can deploy your own private network, that's just the huge first point, is you can deploy it yourself without having to involve a Verizon or an AT&T or a T-Mobile, Sprint type of organization. And it brings capabilities that are needed in a lot of the enterprise spaces. And that's just, like I said before, it's another option to meet business needs. It's another tool in your tool bag. Some of the use cases that I would highlight, as initial, just to frame it up in your mind of where would I even consider this, are more so complementary to Wi-Fi, whereas Wi-Fi might be taking the guest networking, the bulk internet or data traffic that's productivity oriented for your workers or something like that, and then private 4G and 5G might handle some of those devices that are corporate controlled, that need kind of an express lane, or that are very specific to the use cases that 5G solves in the enterprise. So that might be automation within a warehouse or within a manufacturing plant. So they've got a lot of machinery that they're looking at automating and removing manual labor out of the equation. Those have a lot of safety implications, as well as real-time protocols for communication over the network that are very finicky, if you will. They have very low tolerances for latency or packet loss. Some of those, or a lot of those, also have large video components, so that a remote operator can control the system if necessary. So they're autonomous, but maybe an operator is always still kind of monitoring the system and can step in and take control remotely if they need to. Some other use cases are like in hospital or medical environments where you might have critical life safety systems or communication systems for nurses and doctors that need those paging and voice communication systems, where maybe today you're doing it in building with some Wi-Fi technologies, or you've got a legacy two-way radio system. Private 5G can give you both indoor and outdoor coverage across a medical facility and a campus, so that even if those doctors go outside on break, they don't lose access. And then voice is a very native application on a cellular network, so those are very high quality. And then some of the other things are some of the QoS benefits. So with, not to get too deep into the technology right away, but one of the big differences is that 4G and 5G, actually you can schedule traffic and control traffic, and it's not distributed contention, kind of like Wi-Fi is. So with Wi-Fi, anybody can kind of grab the medium and send a frame. With 4G and 5G, the base stations control all traffic downlink and uplink going to and from clients, and they schedule it. So that, that's a huge control factor of, if I have this defined set of mission critical applications that I know need a certain throughput level, a certain latency, or a certain packet error rate that they should be under, I can program that into my network, and that network can prioritize those applications so that even as those clients are mobile throughout the environment at low or high speed, the handover between base stations happens very efficiently so that there's no packet loss, as well as then based on their channel state, meaning signal quality, I can guarantee the application quality that they need as defined by my business policy. So again, if I'm going back to, let's say, voice communications for a doctor, maybe I've got high def voice and it's 128 kilobits per second, right, or 256 kilobits per second. Well, that's going to, I need to make sure I can deliver that not only when they have a great signal right underneath the base station, but maybe when they're 100, 150, 200 yards away outside on a break, and they've got a much worse signal quality. The scheduler in the MAC layer for 4G and 5G can take all of that into account and schedule them more time and change their modulation and communicate the modulation that the client should be using to the client, so that it can have that robust link and connection still and get that data through. So those are some of the high level types of use cases that we're looking at. And there's additional ones with shipping and rail yards and university campuses, which might be very applicable to you, Roel. Yeah. Large outdoor spaces, video camera, security solutions, yeah. Critical systems for, let's say, smart buildings and facilities. We've been talking with a lot of universities that want to get those like fire alarm panels and smart building type IoT type sensors.
Yeah, there's a lot of smart building IoT type devices that the facilities wants deployed all over the campus. So I can see where those are typically areas where there is very not much Wi-Fi already, especially in the outdoor areas.
Right. So I mean, that's another big difference is that from a CBRS perspective, outdoor base stations can transmit up to 47 dBm, which is 50 watts. And that's total EIRP between transmit power and antenna gain. And we can cover, millions of square feet potentially with an outdoor base station on CBRS. And so it really eases that deployment model for large outdoor spaces and coverage of those spaces. And then the same for fixed wireless type scenarios where you've got more of like point-to-point links. With directional antennas, we can shoot a signal on CBRS multiple miles fairly easily and get that link established and that throughput in.
So you can use that as a potential backhaul for another building if you don't have fiber going into it, or maybe there's no ISP going there. You could use 5G as your backhaul, and then even still do Wi-Fi in the building, but using that 5G.
Actually, yeah,
bring back.
yeah. Or if you could think of maybe municipalities doing public safety where they want video cameras on light poles or something like that, but they don't want to trench fiber to every light pole, right? You want to get those devices connected across a large footprint or large area as cost efficiently as possible. Other use cases, retail might be looking at them for mobile point of sale to have a bit more security, get them away from Wi-Fi. It's a bit harder at this point to capture cellular traffic on CBRS than it is capturing Wi-Fi. It's still encrypted and authenticated and everything too. Or those massive IoT deployments. We've been talking with some retailers that want to do potentially hundreds or thousands of IoT sensors in a retail store or a retail setting, and they're just not confident in putting that on Wi-Fi. Number one, just given the amount of devices and the ability to handle that many connections, and number two is just to get them away from potentially their public network and not have them interfere with one another, like just from a congestion perspective.
Yeah, I was going to ask you the question about high density environment, like would like a stadium or any LVP environment be suitable for private 5G?
Yeah, I think you're going to see a lot of deployments in large public venues with 5G. At that point, you're going to be looking at the owners of those facilities are going to be looking at alternatives, and they've got a lot of options because the carriers are going to be as well pretty heavily with their cellular DAS solutions. They're looking at putting in Wi-Fi, and they could look at putting in their own private 5G as well. And so those are going to be some of the environments that are very heavily contested. But then when you look at the medium or your average enterprise, that's even large down to small size, carriers aren't going to be coming in trying to design and deploy 5G in those spaces. They just don't have the business model to support that. So, most of these enterprises want control and visibility of their own data and devices as well, and they don't necessarily want to put them on a mobile network operator.
So if you deploy private 4G or 5G in your environment, can you have some sort of connection back to a carrier to also handle cellular calls?
Yeah. There's a couple of different ways that's possible. So one way is called dual SIM, and that's where you have two separate subscriptions or SIM cards in your device. One can be a physical SIM, one could be an eSIM. And you have essentially two different connections, one to the mobile network operator and one to the private network. And then it's just a matter of device policy on the device to set which one is preference for data traffic. Typically in that scenario, you've got a subscription to the MNO or to the carrier for your 10-digit native dialer and phone number. So the voice is always going to go over the MNO's network. But then for your data network, you can set a preference of should it go over the public or the private network. The other options are that, if you don't have dual SIM, or let's say it's a corporate-owned device where you don't want a subscription back to the carrier's network, which is quite a big possibility, then you could actually negotiate roaming agreements with carriers and actually have your private network and resell access to it to the operators, so that you would advertise the MNO's network into out of your private network equipment, and so then those subscribers would come into your environment and it would look just like the MNO's network, but it would actually be running over your network. And those are a little bit trickier because it requires a business arrangement, but from a technology perspective, it's all standardized with 3GPP. So that's kind of what we term more neutral host type deployment, where I'm deploying a private network, I'm going to resell access to it to the Verizons and AT&Ts of the world, if I can establish that. But there's quite a bit involved in negotiating those types of arrangements.
It might be cheaper than installing a DAS, like in a hospital, let's say.
That's one of the big focuses of Celona from a solution perspective as well. Is DAS is typically a multi-million-dollar investment for any size facility. It's not cheap. They have to pull in their own fiber, their own coax throughout the facility to distribute the signal, and then have all the baseband and all that in racks in the data center. With Celona specifically as a private cellular solution, we can get into what the components are, but we're targeting price points that are much more in line with your typical Wi-Fi deployment for these types of buildings. So an order of magnitude, a fraction of the cost of what a DAS would cost to deploy, and you can get your own private cellular network. Yeah.
And without diving into the components, is it similar to like Wi-Fi today where you have an access point that has the built-in antenna, or are you just deploying various antennas, and does Celona do we get that equipment from Celona, for example?
Yeah, so first off, Celona does offer an end-to-end solution. So we offer a complete package, so you don't have to get anything from any third party. So we can sell you everything required for a cellular network, which is also kind of unique, and because the way cellular networks are built by carriers, they go source every individual component differently or individually and then integrate them together. So having a holistic solution where you can go to one, provider and get everything and deploy it and get one, kind of throat to choke for support is kind of important as well for enterprises. So yeah, so we offer indoor and outdoor LTE access points at this point. Indoor look just like a Wi-Fi AP. They are powered over PoE+. They have backhaul via, Cat 5e or Cat 6 Ethernet. They have dual internal radios that are built in with built-in antennas that have a little bit of down tilt. You'd mount them in your ceilings or on your walls, just like you would a Wi-Fi access point. And so some of the terminology that you might hear for that is either small cell or eNode B in 4G kind of terminology. Evolve Node B is kind of what the radios are called. Or in 5G, it's going to be a G Node B. So essentially, this is where it's packaged in the entire radio, the entire front end baseband, all the way up out to the antenna, all in one compact form factor. Outdoor unit, IP66 rated, external N-type connectors, dual radio again, single mode fiber or Cat 6 Ethernet backhaul. Built-in GPS for signal lock for syncing, which is required for handover and mobility that's high speed and cellular. So they look and feel just like Wi-Fi access points at this point.
Okay, and then centrally, is there like a controller that manage them, or is that all mainly now cloud-based and traffic's just dropped locally on the switches?
So the big component for Celona and part of our differentiation is that essentially the access points, the LTE access points are really the only hardware-driven component in our architecture. Everything else is software-driven. So we have the Celona Edge, which is essentially one of the main functions that it carries out as a cellular packet core. So that's analogous, roughly, not one-to-one, but very roughly, with a Wi-Fi controller. So it's a centralized control and data plane. So the access points register with the Celona Edge as a packet core. They get all of their policy and configuration and radio settings from the Celona Edge. The Celona Edge is a software stack that is built on cloud native kind of microservices. So it's containerized type of software modules that typically right now we run in virtual servers. We also offer it as a hardware appliance for those organizations that are more comfortable adopting it in that fashion. And it can be deployed essentially anywhere you want. You can deploy it locally on premises. So if you have a site where you want local traffic breakout, you could deploy an instance, let's say on a virtualization stack or as a small appliance in a location. Or you could deploy it in a centralized data center, in a hosted colo facility, or you could deploy it in the public cloud, like if you have any public cloud provider and you want to deploy it in that environment. And you can mix and match in one organization. So you can have some sites that have local Celona Edge instances, and you have others that come back to a centralized one, really just depending on what those sites need for their application traffic and architecture.
Yeah, it's not too far off from what we're used to seeing in Wi-Fi and the architectural feel and design is very similar. We're just dealing with different spectrum in this case. But since we're dealing with different spectrum, and a lot of the guys that a lot of people that listen to the podcast, they do a lot of Wi-Fi design. How do you design for this type of spectrum? Like, is it similar to Wi-Fi with different channels that each of these access points would use? Do you use a piece of software to do the design, such as IBWave, to do this? Because I'm sure, like in manufacturing locations, there's a lot of reflection and a lot of complicated environments, complex, that would be challenging for even any kind of spectrum.
Yeah, the design and deployment, from a framework looks very similar to what you're used to with Wi-Fi. So you can start with, tools that give you a rough order of magnitude, maybe for budgetary pricing purposes. So that, you're on the very front end of a project and you're just determining feasibility, maybe setting budgets for the next year. You can get, a rough idea of what you're going to need. So we offer a free web-based tool at planner.celona.io. It's called the Celona Network Planner. It's a very high level, rough order of magnitude. So you put in, your facility address, facility type. It has a lot of back-end regression modeling that it does that's not exposed to you, but it gets you an accurate number for how many LTE base stations or LTE access points you'd need for a given scenario. And that's both coverage and capacity based. So you can say, I have X amount of square feet and I have so many devices and they need this amount of bandwidth. And it'll tell you roughly, how many indoor or outdoor LTE access points you would need. The other key component there is that it does, with CBRS, since it is a shared spectrum, we do need to understand how much spectrum is available at the given location. So we do a real-time query of the back-end spectrum access system, which is essentially a back-end database that every radio that's deployed in CBRS has to register with, and also get a spectrum grant for a very specific channel or frequency of operation. So, high level, the first step is with that Celona Network Planner. Once it gets more concrete on, designing a specific indoor or outdoor facility, there are a number of different tools you can use, very similar to what you may be familiar with in the Wi-Fi space, that actually you put in floor plans, you draw walls, and you do attenuation and heat mapping type of predictive modeling. There's a number of tools on the market right now. IBWave is one that's good for indoor and outdoor. Google is a SaaS provider for the backend database, and they kind of have a beta access to an outdoor network planner that they do. And there's a few others out there like RANPlan and things like that do this type of modeling. So that's kind of your second step for the predictive. Then you go in and you deploy and you do your validation surveying just like you would with Wi-Fi. I think one of the big differences that is going to need to be understood by Wi-Fi professionals that get into this space, though, is you don't design the net. Even though you use very similar tools, you don't design the network the same way you would a Wi-Fi network. And what I mean by that is, yes, you're looking for your coverage assessment of, do I have a given signal quality throughout my environment, and do I have a minimal interference? But the way interference is handled with LTE and 5G is completely different. So in Wi-Fi, there's a huge emphasis on having a very detailed design to minimize what they call co-channel interference, because with Wi-Fi, anyone operating on the same channel, essentially, they're very polite and back off. So if I hear another AP or another client on the same channel as I am, and I can decode their preamble or hear their frame, I'm going to back off and wait until essentially all is quiet again for me to transmit or to attempt to transmit. In LTE and 5G, that is not the case. There is more coordination that happens on the back end, so that across the time domain, transmissions can get scheduled. Again, since LTE base stations or access points control the scheduling very granularly, if the network is not completely congested, it can schedule different clients and APs to transmit at different time intervals and interleave them so that interference is avoided. And if the network is a bit more congested, LTE and 5G are a bit, how do I want to say this? They're a bit different in how they handle that interference. They don't back off completely. What they do is they can still transmit simultaneously. And what you're looking for then is still to make sure that there's just enough separation between APs or clients and APs that can hear one another, that there's a given amount of dB separation so that the intended receiver can still receive the frame that they're trying to receive, rather than the one that's going on simultaneously, let's say, further away. So what that means is, if I have, let's say, two LTE access points that are on the same channel, let's say I have 20 dB of signal separation. So if I'm a client and I'm trying to get a packet from access point A, but I can still hear access point B, but it's 20 dB weaker, what that's going to translate to me is, even though there might be simultaneous transmissions going on from those access points, I only care about one. And since I have that, let's say 20 dB of separation, I can still focus on my frame that I'm trying to receive. And the only impact to me is that, because I do hear the interfering one, I have a bit higher noise floor. So that might impact the modulation and the data rate that I'm using to transmit with my AP. So when people have said that LTE is more efficient and it has higher frequency reuse than Wi-Fi, this is really one of the main things they're talking about, is that I don't have to be as strict with avoiding co-channel interference in LTE. I just need to make sure I have a minimum amount of signal separation, and it might impact me a little bit on the capacity side, but I still get simultaneous transmissions, which is a much bigger net benefit. I can still increase capacity by layering in more APs on the LTE network. Whereas with Wi-Fi, you get to a point where you layer in more APs and it just adds more overhead and you lose capacity.
You have more problems.
So,
okay.
Hopefully I explained that somewhat well.
I think
it's a bit of a complex topic to kind of, without a whiteboard in front of you.
Over audio, it's kind of hard, but I think I can understood that, because with cellular, you have a lot more fine-grained control over that frequency. Whereas where you said earlier, Wi-Fi it's polite, right? You hear a signal, you have to like back off and stay quiet. Whereas cellular, you're looking for that separation, that signal separation. You may have that higher noise floor, but you can still send out the signal and then be able to demodulate at a certain like data rate, for example, like you said. So I think I'm starting to understand like the very good use cases of why an enterprise would want to use 5G or even private 4G. It's starting to make a lot of sense. And
that's how you layer in like very high density environments on cellular. To layer in more capacity, you can actually add more APs. Now you still have to do a pretty, to a certain point, a detailed design, but as long as you can maintain that signal separation, that co-channel interference is not going to kill you, and you can still layer in more capacity to a larger extent. And that's how LTE gets away with providing service with much less spectrum as well. So, if you look at Wi-Fi and the several hundreds of megahertz of spectrum that it has between 2.4 and all of the different 5 gigahertz bands, not to mention how much is coming up with 6 gigahertz. LTE typically has much less spectrum to work with, but can get through almost comparable amounts of data because it can reuse those frequencies much more often in the face of interference.
Now, earlier,
sounds like it's easier to design for.
Yes and no. I mean, it's just different. I would say it's neither here nor there. It's just a big difference that if you're in the Wi-Fi design mindset, you kind of need to shift gears when you come into 4G and 5G. And just like, for instance, static channel planning is not going to be as huge of a deal in cellular as it is in Wi-Fi potentially. Or if you're leveraging, RRM and Wi-Fi, there's an analogous, self-organizing network function in cellular that's very, very similar in assigning the channels and the radio power settings to the LTE access points. So it's just some of those steps where you may be used to going the extra mile to make sure your design is really rock solid with Wi-Fi. You can be a little bit more relaxing and a little bit more forgiving and a little bit more trusting in those automated algorithms with cellular.
So how do you validate that signal separation when you go back on the site? Like, which tool would you use?
Yeah, so you're going to be looking at, your surveying tools at that point. So like, your IB wave or things like of that nature, where you're actually going through and doing what they call a walk test, which in the Wi-Fi world, people call an RF site survey. You're actually walking, not every square inch, but as granular as you can get to have a high fidelity of data of what the signal is and where. And then you can put out all those heat maps of, what each AP's coverage is and what the signal to interference and noise ratio is. And that's really the big thing we're looking for in cellular, is what the signal to interference and noise ratio is. That's really, really huge, because most of the quality of the connection is driven off that measurement, more so than the signal receive power or looking at channel interference.
And so you would use, I'm guessing, USB dongles that can listen and scan these specific frequencies?
Yeah, in the cellular space, it depends on which frequencies you're trying to survey. Okay. For CBRS, yeah, you could do something as simple as a USB dongle or something like that. IB Wave has a number of options that are, more for traditional carriers that are looking to capture a range of licensed frequencies as well. So it gets a little bit more complicated when you're, looking at all the different frequency ranges you want to capture potentially for a survey. But for CBRS, it's fairly simple.
Okay.
Earlier you mentioned some of the tools for the predictive modeling, and you mentioned a term. I think you said RAN. Is that RAN?
Oh, sorry. Yeah. So one of the tools that I mentioned was RAN Plan. They have a predictive design tool out there as well. So I mentioned IB Wave, Google, and RAN Plan.
So RAN
and from a more generic standpoint, terminology-wise in cellular, RAN stands for Radio Access Network. So that's the radio layer. So access point or radio.
Gotcha.
And so that's a terminology acronym that's used quite often.
Yeah, I've seen that before, RAN, and I was curious like how it plays into the whole picture, and I think you just outlined that. That's so in terms of then, let's say you're validating a network. I know interference might be less of an issue with the spectrum, but what happens if you do come across some sort of interfering signal? Is it something like, could it be that somebody else is also using that frequency, or are you the one that is kind of lightly licensed? I know you're not like licensed to use it, but could there be other operators on the same signal as you?
So yeah, that gets back into the CBRS spectrum band specifically, and how the FCC has kind of regulated it. And there is opportunity for some interference, but it's with, kind of known entities. And so that gets into the shared tiered spectrum model that the FCC has kind of defined. And there's 3 tiers in the CBRS kind of spectrum band. The first tier is the incumbents, and these are the ones that get to the highest priority. So this band was essentially deployed by the Department of Defense in the US for specific radar operations, mostly on aircraft carriers. So there's incumbent protection along the coastlines of the US, where if an aircraft carrier is detected using a small slice of this band, so the band is 150 megahertz, an aircraft carrier might be using 5 to 10 megahertz at most of this band when an aircraft carrier comes near the coastline. We don't know exactly what they use it for. DoD is a little bit secretive with that. They don't want you to know exactly what they're using. But when that does come into proximity of a coastline, those back-end spectrum access system database providers have also been tasked or charged by the FCC with deploying a sensing network, or an ESC, along those coastlines. So this is very roughly analogous to what happens in Wi-Fi with DFS, or dynamic frequency selection, where in Wi-Fi, every radio is looking for radar signatures to tell it to, if it identifies one, to vacate the channel. In CBRS, every access point does not need to implement that. They're implemented and centrally coordinated by the SaaS vendors along the coastlines. So the SaaS vendors have deployed their own sensing network along those coastlines that feed into their system. And then the CBRS radios that, for instance, you might deploy have a heartbeat mechanism with those backend database providers. And if they're operating on a frequency that, and within proximity of an aircraft carrier that comes along the coastline and is known to be using that slice or that channel that you're on, then the SaaS vendor will communicate with your radio and tell it to vacate the channel and move to a different one. And I believe that has to happen within 60 seconds.
Okay.
So yeah, so centrally coordinated, sensing for military radar versus Wi-Fi, where it's implemented in every radio. So hopefully, since it's centrally coordinated, it's a bit more robust, a bit more, accurate, and not prone to false positives that you might be.
That we usually see on Wi-Fi. Okay. For someone like me and Francois, can we deploy private 4G and 5G in the enterprise? And if so, where do we go to even learn about this technology, like from at a Mac and physical layer? I know we've got like CWMP books that we usually reference for Wi-Fi. Like, what about on the 5G side?
Yeah. So first off, yes, you can deploy your own private 4G and 5G networks. The caveat there is that there's two classes of radios in CBRS. One is category A, which is low power, and category B, which is higher power and outdoor only. So essentially, that's roughly analogous to an indoor versus an outdoor AP, but it's not quite a one-to-one mapping. For an indoor, the low power AP, you can deploy it. Every device, whether it's indoor or outdoor, has to be FCC certified. And part of that is that they will interoperate with the backend SaaS database providers. So as long as you're buying an FCC certified device, it will work with the SaaS vendors, and it will coordinate spectrum grants and incumbent protection and all of that. For outdoor deployments where it's higher power, so indoor is limited, or the low power is limited to 30 dBm. Outdoor or high power is limited to 47 dBm, so quite a bit higher power. And so there's a higher risk of interference to the incumbents potentially. So in order to be able to deploy an outdoor high power AP, you have to go through what's called a certified professional installer program. And those same SaaS database providers have online training modules where you can go. It's usually about a 6 to 8 hour online training with some quizzes along the way. That I think it costs about $600. And then you get your certificate and you can deploy outdoor. So what happens then is if you deploy an outdoor radio, you have to sign off with your certificate that you get out of the program of the installation details of this AP is deployed at this location, at this height, with this antenna gain facing this direction, to make sure that the information that goes into the SaaS database for the spectrum grant and the interference modeling and incumbent protection, that all that data is accurate. Essentially, you're signing off and you're liable for that installation.
Yeah. You put your name
so as
on
long
it.
as you've done that, you can deploy outdoors. So then to get started, I mean, you just look at a provider like Celona, buy your own equipment like you would from just any manufacturer that you buy equipment from. And Celona just happens to be, one of those in the space. And then you could go and deploy. And that's really all there is to it.
How about
do you know about other countries? Because I know CBRS is for the US, but do you know if other countries have other similar private LT solutions?
Yes, absolutely. So a lot of countries are looking at what the US is doing and looking to adopt similar if this is successful. So I know that Germany already has lightly licensed spectrum. It's a different paradigm. So CBRS is going to be fairly specific to the US, at least right now. Other countries are doing something similar, but they might have their own twist on the regulations, right? So Germany, I think you have to apply for a small fee to get access to a lightly licensed portion of spectrum, but then it's very similar. UK is looking at that. Canada is looking at something similar to CBRS. So there's a number. I think the EU is looking at something similar. So there's a number of countries that are looking at what the US is doing and will be following, I think, fairly quickly. But Germany's already active, I know, and they're deploying private cellular in industrial and manufacturing type facilities already.
Okay. All right. I had a question related to the 3GPP. I think it's important for people to know about this. In the Wi-Fi world, we have the IEEE, which comes out with the publish the standards. In the cellular world, they have the 3GPP. Would you compare the two organizations, or are they different in what they do?
Yeah, so cellular organizations wise, there's two main ones you need to know. One is 3GPP, which is really setting the technical specifications and recommendations for the technology. And they're not really a standards body per se, even though they function what you would consider to be a standards body. That's actually handled by the ITU. And so what happens is the 3GPP makes recommendations on technology specifications. They get ratified by the ITU at every so many years at a global forum. I can't remember the name of it right now. So essentially, those are the two organizations that you need to know about.
Okay.
What about learning the like Mac layer side of things, like really nitty gritty details of how the technology works? Are there resources you would recommend us to look at to really know how it works?
Yeah, absolutely. That was part of your earlier question. Sorry, I didn't get to that. So it's fairly steep learning curve. I'll tell you up front, which is part of the barrier of why it's kind of been inaccessible to a lot of people is you kind of have to go source your own books. So some of them that I would recommend are LTE in Bullets. You can find it on Amazon or other online bookstores. There's a 5G in Bullets book as well. They're fairly technical, reference books. So they can be kind of a slog to get through. And that's one of the areas of focus as well for us at Celona is on our website. We've got a number of articles and videos that we're trying to put out to educate the community on what 4G and 5G and CBRS and how this technology works. So, for introductory level content, definitely check out what we have on our website on celona.io. And we've had some webinars and things like that. If you really want to learn the PHY and the Mac, unfortunately, you have to get some of those technical books and just kind of dive in, and it's going to be slow going at first. But the other thing is, from an introductory perspective, I did a presentation or a deep dive at Wireless LAN Professionals Conference this last February. And I go through kind of a lot of the high-level introductory from terminology, what those standards organizations are, how CBRS works, and the high-level technical aspects of LTE, so that you have some sort of baseline foundation that when you jump into those larger technical books, the terminology does. You're not hunting for information that is assumed to be known in some of those manuals or some of those books, and can get you kind of up and running a little bit faster. So I would say check out on YouTube the free videos from WLAN Professionals Conference in February.
Okay, yeah, because I think they published that one for people to see.
Yeah, it should be free out there on YouTube.
Okay.
Yeah,
we'll link out to that.
That's really good.
Yeah, I just found it.
I wanted to talk about the devices to, which devices would support private LTE or 5G? Is it like the same devices that would support typical cellular connections, or do you need a specific chip to support those new technologies?
Yeah, so CBRS is just another LTE frequency band that can be supported. So it's technically called band 48.
Okay.
And so newer LTE or newer cellular chipsets that support band 48 will support CBRS from a chipset perspective. And then you also need to check with the manufacturer of the device from the software perspective to see if they've enabled it in their software. So from a high level, if you look at what chipset is in a device and look up that chipset, if it has band 48 support, you should be pretty good. And from a Qualcomm perspective, who manufacture most of the chipsets in the cellular space, they've supported band 48 in most of their chipsets since I want to say September or October of 2019. So new devices that are shipping should have CBRS and private 4G kind of connectivity kind of built in. Some of the ones that we've been testing early on, like the iPhone 11 device lineup all has built-in CBRS support. The new iPad Pro that came out earlier this year in 2020 has built-in CBRS band support. And there's a host of Android devices as well, like the Google Pixel 4, some LG ones, Samsung,
I think the
S10, Note 10 type of lineups.
So all I need to do is get equipment, and I can use my S10 to test it out.
Yeah. What about IoT devices, or regularized devices you would find in a manufacturing environment?
Yeah, so there's a whole host of both gateway router type devices as well as industrial, hardened devices. So there's devices like cradle point routers that are just more generic but have smart routing capabilities where, a number of gigabit Ethernet ports support a number of different cellular technologies for backhaul, and one of those is CBRS. So cradle point is a big, kind of generic router gateway type device. Sierra wireless devices are used in a lot of industrial and shipping type environments as well, like in vehicle and in cabs and things like that. Same type of thing. Smart device supports multiple cellular backhaul options, one of which is CBRS. There are other, kind of generic devices that support IoT type devices, more like bridge type devices. So there's the BEC type devices. One is the MX240 that we recommend quite a bit. It takes an Ethernet connection from an IoT type device or a smart building type device and can bridge that over a CBRS cellular connection as it's access back into the network. There's USB dongles as well out there. We have a fairly large list on an article on our website on Celona.io as well of all the different types of devices that are out there. And that ecosystem is growing quite rapidly. So definitely a lot of use cases. I mean, if you had asked us 9 months ago what devices were out there, it would have been much slimmer, but they're kind of coming out by the handful at this point.
Yeah, that's great. And just because we're already at an hour here, but you guys are going to be presenting at the Mobility Field Day 5, which, as we're recording this recording of this podcast episode will go out much later, but it is on July 29th. And it will be recorded. You're presenting with two other people. What should we look out for in that presentation without giving out too much?
Yeah, so we're going to be covering a lot of. So we presented at the last Mobility Field Day as well. Rajiv, our CEO, and Mehmet, our CTO. That was back before we were really publicly known or had launched. So at this point now, we're going to be going over on the live stream, the Celona technology and solution stack, what some of the advantages are, and why people would consider, private cellular networks as a technology. So very similar to what we've discussed here today. We also will have some additional recordings that we're going to be sharing a little bit later this year when we have our commercial product launch. So it's going to be kind of a two-part for us at Mobility Field Day. Some of it's going to be live, it's going to be available right away, and then there's going to be some of it that we're recording in advance for a little bit later this year that will be released once we launch our product as well. So can't give a little bit more insight into that, but some cool things that we're going to be sharing with the delegates and everybody will have access to here in a little while.
Very cool. Looking forward to that because I already bookmarked it, or not booked. I put in my calendar to watch you guys on this upcoming Wednesday.
Excellent. Yeah, looking forward to it. The Tech Field Day crew is always pretty great to work with.
Cool. To end the show, Andrew, where can people find out more? How can they interact with you online? Let us know.
Yeah. So I think the main avenue for people to engage with us right now is just at our website, Celona.io. We have a evaluation application there. So if people are looking at the technology, they can go learn about it on the articles and webinars and the free content we have out there that we're publishing almost several times a week at this point. We've got sessions that are with our CTO about the technology. We've got videos from JR and our technical marketing team where they're more practical of how do I connect this device? What does it look like when I try to run this application? How do I do QoS? Things of that nature, very practical. And then I have some videos out there that are more field journal type videos and articles around practical things in the field as well for deployments and learning the technology. And then if you want to have a deeper conversation, definitely fill out an evaluation form or attend one of our webinars, and we can hook up on a call and we can give you a rundown of the product and the technology in more of a private setting, with you or a few of your peers in your organization, and really help you flesh out, what use cases might be applicable in your environment. So that's some of a lot of the work we're doing with partners and customers right now is helping educate them on what the technology can provide and what use cases it may be a good fit for in your environment, really after listening and learning about what you do. So.
Very cool. Francois, you want to add anything?
No, I guess actually I watched some of the videos you guys do, and it's really good. So we'll put a link in the show notes so people can find them. It's on the website under resources, and you have a video tab, and then you guys have some sort of playlist. So you talked about the field journal, the JR, the office hours, and they're really good. And you can also find them on YouTube, on your YouTube channel. I think it's called Celona Team. So they're great to learn more about the technology. What I would like to see though is some tests, like maybe we'll see that at Mobility Field Day, like real tests, maybe comparing, latency and some metrics to Wi-Fi and see, different applications in different environment.
Absolutely. And one other thing that I would mention is that probably by the time this podcast gets published, we will be launching our community forum as well. So it's at the community forum is called Frequency. So it's frequency.celona.io, and we'll have lots of information there that we're going to be publishing, as well as just discussion-oriented conversations in a community type of forum for cellular, for private 5G, for CBRS, and for our own solutions. So definitely check that out as well for frequency.celona.io.
Awesome. Thank you for joining us on this episode to talk about 5G, kind of an introductory there. And hopefully in future episodes, we have more of a deep dive into the actual technology itself, and encourage people to check out the show notes so that way you can see all the resources and get to know how you could use 5G if there's a use case for you there. I'm sure there is, especially for us that are doing Wi-Fi in complicated environments where 5G may be the better solution there for whatever your requirements are. But we want to thank you again for joining us on this episode, Andrew. It's a pleasure to have you here.
Thanks for having me, guys.